Hey folks, so what we're doing here is pushing the rigor a little bit. So these are going to be a little bit more challenging. Either they're going to have a couple extra steps, or we're going to use more than one of our derivative rules at once, or we're going to do some applications involving our particle motion problems here a little bit later. So the goal here is to kind of approach an AP level of questioning. These questions are all from the AP question bank, as are the questions on your quiz. You are going to see one more question on your quiz that we're not going to approach here, and that relates to the tangent lines to trig functions from lesson 1.2. Okay, so it's actually several parts at the end of the quiz, so expect that as well, a question relating to those trig derivatives from lesson 1.2, and you're free to go back and look at that if you need to. Okay. As always, feel free to skip around in this video, watch just the ones you need, make sure you understand all the questions before moving on. So for this guy, we're going to do chain rule. So the derivative here is going to be 3 sine x squared. So that's like the derivative of u squared, or sorry, u to the third would be 3u squared. Right, and then we want the times du, the derivative of u. So here, the derivative of sine is cosine. Okay, so this is just testing if you know the chain rule or not. You get. Hopefully that one was pretty easy. Next one, you might be initially thinking, uh-oh, right? This looks like a limit. We don't know how to evaluate, but actually, what this is really just the limit as h goes to 0 of f of x plus h minus f of x over h, right, for f of x equals e to the x. So this is really just asking us to take a derivative, and notice it's got a 2 in there. So for f of x equals e to the x at x equals 2. Okay, so this is just a limit definition of derivative. So what the test is asking you to do here is just take the derivative. And what they're really testing is, do you know the rule? And do you know that this is just a derivative? So the derivative of e to the x is just e to the x. So f prime of x would be e to the x. And then we want f prime of 2. Well, that's just e squared. So this one is actually very easy. Okay. So make sure you can recognize that. That's super common. And it's easy points in the AP exam. You should be getting those, right? So this is the limit definition of a derivative. All right, this one. Again, one that looks scary, but is really not. So we want the derivative for some a bigger than 0. And the key here is a is also, we're going to treat it like a constant, meaning a number, right? So what we'll do here is we'll do chain rule. So a is just chilling. And then e to the anything, the derivative is the same, right? But then we have to do chain rule again. So the derivative of this guy up here, negative ax as well, negative a. So we'll multiply times negative a here. And then notice a times a is a squared, so negative a squared, e to the negative ax. So that is e. Okay. This guy, ln f prime of 2, well, f prime of 2 is going to be, f prime of x is just e to the x, right? So f prime of 2 is going to be e squared. So really this is asking us, if we're going to plug this in, ln of e squared. So remember, the log and the exponential are inverse operations. So these two things cancel out, and all that's left is just plain old 2. Okay, so all these pretty easy. They just require a little bit of insight, right? So this one required you to know that like log and exponential are opposite, which you should know from last year. We'll do just one more. And again, this one, not so bad. Find the acceleration a of t of the particle at any time t. And we have v of t is given by 1 minus sine of blah, blah, blah. Okay, so a of t is going to be the derivative of v of t, right? So a of t is equal to v prime of t is equal to, the derivative of 1 is just 0, right? Derivative of sine is cosine, 2 pi t. And then chain rule, right? So we want the derivative of 2 pi t. And that's just going to be 2 pi, right? Times 2 pi. Okay. So I'll make it look nice. I'll say a of t is negative 2 pi cosine 2 pi t. And then of course what I could do is I could make you evaluate this. So I could be like, what's the acceleration at t equals pi over 2? And then you plug that in, right? So look for what these questions on the quiz are telling you to do with these position, velocity, acceleration functions. Okay. So overall, not so bad. Remember, you are welcome to reference this while taking the quiz, and you're welcome to go back and reference any of the lessons prior to this.